Okay, okay, okay. And anything more?
Sir, can I ask something? I'm Preeti. Yeah.
Yes, you can always.
Sir, can we simplify, I mean, all these subtraction, addition more? Can we simplify it more at advanced levels? Or, I mean, sometimes we have to do calculation. I mean, we have to, without using pen and paper, can we do it mentally?
That demands little practice, nothing else. You
Okay,
can do it mentally.
mentally.
Try for some simple example first,
Right.
and then go for the lengthy examples.
Okay.
It happens. It happens. Start with two-digit addition, two-digit subtraction, then go for three-digit.
Okay.
Once you have a command over that, then go for 4 or 5 digits.
Okay. Okay.
It
I
is
mean,
possible always.
formulas are same there is no advanced level of it. I mean, with practice only we can. Yeah.
Yes, yes, by practice only. Uh,
Okay.
whomsoever says that there are quicker methods than the existing are
Right.
always applicable for the particular cases.
Okay.
Just like you can multiply by 99 very easily, but
Right.
that becomes a particular case.
Fine. Right. Thank
Okay,
you,
we
sir.
will start now. It's 10:05 already. As usual, we begin with the prayer. Slide is visible? Yes.
जी सर विजिबल है
Yes, sir.
विजिबल
Yes, sir.
Good. Yes. We start with Guru Vandana. Shri Ganeshaya Namaha. Gurur Brahma, Gurur Vishnu, Gurur Devo Maheshwaraha, Guru Sakshat Parabrahma, Tasmai Shri Gurave Namaha. Ajnanatimiraandasya Jnananjanashalakaya Chakshurunmilitam Yena Tasmai Shri Gurave Namaha. Tasmai Shri Gurave Namaha. Tasmai Shri Gurave Namaha. Before going to the Leelavati part of today's unit, one query was there regarding this Guru Vandana and a pronunciation slightly. So there is one stotra named as Guru Ashtakam, means 8 verses in that Ashtakam, and every verse ends with the same line, Tasmai Shri Gurave Namaha. Out of those 8 or 9 even, sometimes 9 or 10, I have selected the 2. Both are, first is familiar, second may be new to you. But regarding the pronunciation now, let me tell you 2 very important things. One, in the first verse, there is a word Brahma repeated 2 times. Guru Brahma and Sakshat Parabrahma. Please note that it is Ha first and Ma later. Ha halanta followed by the Ma complete. So our pronunciation should be Brahma and not Brahma. I repeat what I am saying. It should be Brahma. Ha first, then Ma. Brahma. And it should not be Brahma. I think you are getting it. So first word should be pronounced like this. Gurur Brahma. Similarly for Sakshat Parabrahma. So wherever or whenever the word Brahma comes anywhere, it is her first, ma later, not Brahma. Don't write Brahma. Don't pronounce Brahma. It is Brahma. I hope you are getting what I am saying. Similarly, a common pronunciation, which is of course incorrect, it about the fourth part. Tasmai Shri. Many times people used to say, and we used to listen, Guruve Namaha. That is incorrect. There is no Rukar. First is okay. Guruve Namaha is incorrect as per the grammar of the Sanskrit tells us. It is just like this. Just try to understand. There is a rule. And the rule is, whenever we say Namaha to anybody, the word attached to Namaha should be of fourth case, as it is called Chaturthi Vibhakti. It may be plural form or singular form. Here, of course, it is a singular form, Ekavachan, Guru. So we always there, it is a rule of the Sanskrit grammar that Namaha should be attached with Chaturthi case, fourth case, Chaturthi Vibhakti of the word you are saying Namaha. It is just like, we don't say Shri Ganesha Namaha. No, we say Shri Ganeshaya Namaha. Only because Ganeshaya is the Chaturthi of Ganesha. Similarly, we say Keshavaya Namaha, Narayanaya Namaha, etc. Madhavaya Namaha. We know all this. Why that ya every time? Every time ya is only because the respective Chaturthi Vibhakti is like that. About Vishnu, we don't say Vishnu Namaha. We say Vishnave Namaha. Or most popularly, Shivaya Namaha or Namah Shivaya. So this Vishnave Namaha, or we used to say Bhanave Namaha. Original word is Bhanu. It becomes Bhanave because it is Ukaranta. Last vowel is Ukar. In Sri Ganesha, last vowel was A. That's why it becomes Ganeshaya. Why it becomes, it's again a technical part of the grammar. But whenever any word ending in U, like Bhanu, Vishnu, it will be Vishnave Namaha, Bhanave Namaha. Same case for Guru. It will not be Guruve Namaha. We don't say Vishnuve Namaha. We say Vishnave Namaha. Akar is there, no. Same case here, Gurave Namaha. So please avoid these two commonly noticed incorrect pronunciation when we say this Vandana. Other part of this, there are 2-3 more things which I would like to share with you about this, but it will follow next time. Otherwise, our time will be not be there. It is not our class of Sanskrit grammar, but still we must know some elementary things which we are using every day. Let us move further. Last time we conclude with the square. Now we come to the Ganesh Vandana by Bhaskaracharya. Just to remind us what Bhaskara was saying. Pritim bhakta janasya yo janayate vignam vinignan smritaha tam vrindaraka vrindadam natva matangananam. By celebrating Ganesha, who bestows bliss and happiness on devotees, by dispelling the obstacles when remembered, and whose feet are revered by host of gods and deities. So Bhaskara starts with saluting or by namaskara to Lord Ganesha, and then say, Patim Sadganisasya Vachmi, Chatura Priti Pradam Prasfutam, Sankshipta Ksharako Mala Malapadair, Lalitya Leelavatim. Vachmi means I expound, I shall tell. The book of algorithms of auspicious mathematics, inverts which are concise, lucid, flawless, and the book which would provide delight to experts, absolutely unambiguous and full of playful elegance. So with this commitment, now we move to the next part of our session of Lilavati. We go to cube. So let us see what Bhaskara is saying about the cube. Here also he has discussed 3 methods for the evaluating the cube according to the pattern. First, the definition. First line is the line of definition. Samatrighātascha ghanaha pratishthah. Means when we multiply same 2 number. Samatrighāta. It is called as by learned pupil as ghana or a cube. So a simple definition, product of 3 equal numbers is called cube of the number. The step of the first algorithm says that if it is a 2-digit number, say AB, then we will write cube of the last in the sense leftmost or the highest place digit, say A cube. Stapyo ghanontyasya tatontya vargaha. Then multiply 3 times square of last part with first. Means there are only 2 parts. So it will be 3 times A square B. So first we will write A cube, then 3 times A square B, followed by 3 times part with square of first part, 3AB square, and the last of course B cube. Write the cube of the first part, Adi Ghanascha, and Sarve Sthanantaratvena Yutaha. So add all the parts place wise. So we will be keeping those parts place wise at the outset. So A cube, we write the digits or the answer of the 3A square B place wise. Place wise in the sense that 1 digit to the right. So we start writing that way. Let us see by the one below another place wise. Not exactly one below another, but by shifting the digit to the right part, and then we add vertically. So the parts are just the expansion of A plus B cube. It is A cube, 3 times A square B, 3AB square, and B cube. Let us have one example for practice. 23 cube. So 2 cube is 8. 8 is placed first. 3 times 2 square into 3. 3A square B. It is 36. 36 is written as 3 below 8 and 6. So tens place digit 3 is written below unit place digit of the previous part. And that process will continue for 3AB square. That is 3 into 2 into 3 square. So 9 into 6 gives 54. 54 will be written 5 below 6, 4 to the right of it. And the last part, 3 cube, 27, 2 below 4, 7 to the right of it. And all the parts are added vertically to give the answer 7, 4 plus 2, 6, 6 plus 5, 11, and 8 plus 4, 12. So final answer for 23 cube will be 12167. Let me tell you very clearly that it may happen, in some cases, that the product 3A square B or 3AB square is a 3-digit number. Say if it is 1610, 160, say, then I will put that one of the 100 place digit below 3 of the 36. So only one digit will be outside the range. Remaining all will be placed according to the previous places. Let us have that example. Okay, it is 15 cube is coming. Start writing 15 cube. 1 cube 1, it is easy to calculate. 3 into 1 square into 5. So 15. So 1 5 we will write. Then 3 into 1 into 5 square, 75. We write 7 of 75 below 5 of 15. And the last 5 cube, yes, that's come, 125. So that 125 is to be written. Don't write 1 below 5 and 25 to the right of it. No. 1 is to be written below 7, 2, 5, and then last digit 5. If you miss this adjustment, then you will get the incorrect answer. Final answer is 3375. Here it is 5 cube is 25. So 5, 6, 7, 8, 9, all are 3 digit. All have a cube 3 digit number. So whenever a number at the unit place of any 2 digit number is greater than 5 or equal to 5, last cube will be 3 digit. So you have to keep that way. Similarly, as I said, it may happen that 3a square b or 3b square a will be 3 digit number. Accordingly, we will place it. Let us have this example. See where 47 cube. Four cube 64. 3 into 4 square into 7. Take a minute to write the answer first and then place it. 3 square. 336. Correctly placed as first 3 below 6, second 3 below 4, and 6 to the right of it. 3 into 4 into 7 square, 558. Similar placement. Starts from the tens place of 336. So one digit will go to the right of the system. And 7 cube 343. Vertical addition gives 103823. Try this 62 cube. Start writing the answers. Six cube 216. Next will be again 216, because it becomes again 6 cube. 3 into 6, 6 square. Only because of that 62 number. That 216 is to be kept like this as shown, and as we know it now. Then 3 into 6 into 2 square becomes 72. 72 is to be kept as usual. 7 below 6, 2 to the right of it. And then 2 cube 8. You can consider it as 08 and write 0 below 2 and then 8, or directly 8 to the right of 2, whatever is convenient. Vertical addition gives 238328. It is an algebraic method, no doubt about that, because a plus b cube expansion is used. Similar to in the square method, it was a square plus twice ab plus b square is used in the first method. Here that expansion is used. So there is a perfect blend of algebra and arithmetic calculations in Lilavati. Now try this exercise. Find 24 cube then 71, I will give you 2-3 minutes for this. Go slow, but correct answers. Don't rush to get the answer. First, you should go slow, and then only after practice, you can write it as early as possible, with as speed as possible. I'm sure you are getting the correct answers. It is always better to remember the cubes of 1 to 9 so that this method can be applied easily. In addition, we always know squares, but try to remember the cubes from 1 to 9 so that you need not calculate what is 9 cube. If you remember it, you can directly write the answer. Now let me allow to move for the next part. You can select many more examples like this of your own. Cube of the 3-digit number. This is again a slightly difficult. Cube is itself difficult, but cube of 3-digit number will be a bigger number always. So Bhaskara says, I hope you are now with me. Cube of 3-digit number. Prakalpya tat khanda yugam tatontyam evam muhu. Muhu means what is to be repeated similarly. Then what is to be prakalpya means what is to be imagined or what is to be considered. Khanda yugam. But how to select those parts? Khanda antyam means out of the 3-digit number ABC, I can select A and BC or ABC, AB one part, C other part, or A one part, BC other part, like that. But a special instruction, tato antyam, means we will consider the parts as AB and C as the another part. And the earlier process is repeated. So for AB, I need to follow the previous process. And to that process, I need to connect ABC. Let us see how it happens. 318 is the example. So we break it into 31 and 8. If you break it as 3 and 1, 8, answer will be wrong. That's why the special instruction. From left, select 2 digits always. Similar procedure is continued for 4 digit, 5 digit, so on. So find 31 cube. We don't know 31 cube. Apply the previous method. So 3 cube, 27. 3 into 3 square plus 1, again 27. Oh, sorry, it is a mistake. It should be 28. Huh? Correct it. 3 square, 28, not 27. Then 3 into 1, 9. And 1 cube is 1.
Sir, 27 ठीक है. ये इसमें प्लस नहीं होना था. This is 3a square b है.
Yes.
3a
Yes.
square.
Oh, yes. Thank you. Yes, the plus is a mistake. Thank you. 27 is correct. Then 3 into 3 into 1, 9. So answer is 29791. This is for 31 cube. Now for 318 cube, same rule is to be applied. But when I start applying the same procedure, I will require 31 square also, 3a square b. So it is better to calculate that a square separately. So before going to 318 cube, calculate 31 cube. By anticipating that, we will require it. So 31 square is 961. So it's a lengthy job, I agree. Many calculations are to be done simultaneously. Now proceed for 318 cube. It is 31 cube. We have the answer 29791. Then 3 into 31 square into 8. Answer is before you, so we will not give much time to that. 23,064. See how it is written. Only 4 to the right of it. Other 4 digits are written accordingly. 2, 3, 0, 6, and 4. One digit only is to be shifted right. Then 3 into 31 into 8 square, 5952, accept it. Write it accordingly. 595 below 064 and 2 to the right of it. 8 cube is 512. Write it accordingly. 512. And now add. Answer is 32, 32157432 when we add vertically. It's a lengthy procedure. And of course, even by routine method, 318 cube will be a lengthy procedure. But after practice, we can reduce the number of steps. But after practice, don't rush to reduce the steps in the first 4 or 5 examples at least. Next, 426 cube. Start writing without looking to the screen. 42 and 6, remember, are the parts. I repeat, 426 will give incorrect answer. Four cube, then another 42 cube is to be found first, then 42 square, and then start writing for 426 cube. You can select the answer of the product from the screen. It's a matter of writing, more important. Don't use calculator, nothing. Try by your way. Again, some mistake may be there. Nice, it's all right. Only that plus sign is missing. It's additional there. I will correct it after this session.
Sir, in the last step, 2 cube equals to 8. Is this 8 below the previous 8 or?
No, to the right of it only. You can say 0, 8 and write 0 below 8 and 8 will be to the right side. One digit is to be shifted every time.
Yeah.
46 cube, then 346 square into 6, etc. As I said, go slow, don't worry about the time. Once the method is properly understood and have a command over it, answer will not be wrong. Those who have finished can try this exercise. (135), first one. Find cube of 135. Yes. Yes, Rudra, anything?
Yeah, sir. Earlier, like when I was like doing calculations, I was getting incorrect answers. So
okay.
I was like not very clear, like what does shifting one digit means. So means I'm just general input. Then what I realize is basically you have to shift, like start from the right hand side with one digit shifted and then start writing it leftward. Then it will be fine. Otherwise,
that's a good idea.
I was having like a difficulty because the column
that you can follow.
And
that you can follow.
Started making sense. Yeah.
Okay.
Earlier, like I got like a couple of answers wrong, and then thank you, sir. So,
okay. Maybe that's a good idea, rather.
Yeah. So then we will not have misalignment of the digit. So sometimes if the product is of 2 digit or 3 digit, we will not have that misalignment, you know. So like if the answer is 125, then we should write 521 from right to left. Then they will automatically adjust in the proper column.
So first get, it is, that is the reason I said that first get the actual answer and then place the digit.
Right. So like in the end, say like
in any one way,
yeah, it's okay. Good. Thank you, sir. I got it. Okay. But I thought maybe other people will also struggle and then they may get wrong answers. You know?
Okay.
Thank you, sir.
Unstable.
So let us move to next part. You can complete the examples. Four, 5, 9 will generate 3-digit number, 3 into 5 into 9. Otherwise, I don't think anything is unfamiliar. Okay, please attend the screen now. Second method for finding the cube. Again, he is using the algebraical identity as you are seeing on the right corner of the screen. He is saying parts remaining the same, multiply 3 times the product. So 3 times a plus b into ab. Khandabhyam hato rashis trignaha. Means whatever the parts are there, first multiply and then add, or first add and then multiply. 3 times a plus b, ab. And then add khanda ghanaikya yut, means add the cubes of the parts. So if a given number is break into two parts, x is break into say a plus b equal to a plus b, then I will use the identity 3 times a plus b into ab plus a cube plus b cube, or you can say a cube plus b cube plus 3 times ab into a plus b, whatever way you adjust it. Just have one or two illustrations before we go to third method. 73 cube. 70 plus 3 is a better assumption, so that 70 cube can be written easily. 7 cube 343. 1 0 generates 3 0 in the cubes. So final answer 73 cube will be 343000. A b cube is 27. And then 3 times product 70 into 3 into the sum 73. Again, this will take little time to get the final answer. 370 and then 73. 3ab into a plus b. So 3 times 70 into 3 into 73. 45900. And once we get the answer, we need not have any shifting of digits, just add as usual. So 34 3000 plus 27 plus 45990 gives the answer 389017. So this is advantage, you can say. You need not worry about the placement of the digits, but drawback is the third product. First cube may be easy because every time we will be trying to break the number into parts such that it contains at least 1 0, so that I can write the cube easily. But that product 373 multiplied by a plus b, 3ab multiplied by a plus b may take little time. 45 cube, start. Select 45 equal to 40 plus 5 whole cube. Then 40 cube means 4 cube 64 and 3 zeros. So 64,000. 5 cube 125. Then 3ab means 340 50. I'm sorry, 345. And a plus b is 45. So 27,000 is the answer. Of course, by good permutations, you can have the product like 5 into 3, 15, 15 into 40, 600, and then 6 into 45, 270, 270, 00. That becomes a simpler part. Simple, without doing 120 into 5 into 45. Just look to the pattern. 15 into 40 gives 600. And 6 into 45 gives 270. So final answer will be 27000. That will save our time. Then write according to the places to get the answer 91125. This benefit of having some workable permutations will be always there, because in the parts, one part at least has 1 0. Try this 28, 54, and 76. First answer 21,952. For 54 cube, it is 157464. And the third one, 438976. Coming back to our next discussion is the method number 3. It is a particular case or a method for only for perfect square number. So heading itself tells us that it is a cube of the perfect square number. This is a particular case, not applicable to any other numbers. If the number whose cube we are interested is a perfect square number, like 9, 16, 64, 125, etc., then the cube can be evaluated. But it is just an academic interest method, nothing special in it. Bhaskara says, Vargamula ghanaha swagno vargarashir ghano bhavet. Vargamula ghanaha means take the cube of the square root. Multiply it, swagno means itself. Then it becomes vargarashir ghano, means it becomes the cube of the square, perfect square number. In short, if A is a perfect square number, then A cube is square root A cube multiplied by square root A cube. That is Swagno's self-multiplication. So what he is saying that if the number whose cube is to be found out is perfect square and whose square root is known, then you can just apply the method of finding root A cube multiplied by root A cube. Again, I repeat, don't try to apply this method for any number. It is applicable only to perfect square number. Let us take two examples. 9 cube. 9 is a perfect square number. So we find its square root first, that is 3. Then cube of the square root, that is 3 cube, is 27. And then 27 into 27 is 729. That's why 9 cube is 729. It looks strange sometimes, but answer is right. And of course, it obeys the law of indices. Square root of a cube, it becomes cube. Multiplied by square root of a cube. So powers get adjusted. 3 by 2 plus 3 by 2. Then see 64 cube. 64 is a perfect square number with square root 8. So I will find 8 cube and then square that 512. Sometimes these methods are useful, not every time, but. So 64 cube is 262144. And if you don't know the square root, then again the problem arises. Or if the square root itself a two-digit number, then again I have to find the cube of the two-digit number separately, then square it. So as I said, it is not a very applicable method in all cases and not even advised to be applied. But it is given, that's why I have discussed it. Cube of a perfect square number. Now we move to the next unit of our discussion today. It is square root. We may not be able to finish it all the cases. We will continue next time. Let us see how much we can complete. So it is a long verse with very difficult words in it. Tyaktva antadvishamat kritim vigunena moolam sameta trute. Tyaktva labda kritim tadadya vishamal labdam vinigdham nyaset. Panktya panktirute samentya vishamat tyaktvat varagam phalam. Panktyat tadvigunam nyasediti muhu pankter dalam syat padam. So instead of going again to the language part of it, let me allow to go to the algorithm part, what Bhaskara is suggesting. Don't compare this method with the method which we are using today. I'm saying it initially. Later on, once you get the correct method, correct way of finding the square root by Bhaskara method, then start comparing. And secondly, also don't mix the two methods. That will be again a problem. So let us see what Bhaskara is saying. I have put it in a table form. First step, group two digits at a time from right to left. That we used to do for square root even today. Or that instruction is followed even today. Then consider a leftmost part. Leftmost part may contain one digit. If it is 3-digit number, it may have two numbers. If the given number has 4 digits. Similarly for 5, similarly for 6, it will go on. Either one digit in the left part or 2 digits in the left part. Accordingly, we select the nearest left square. So by observing the leftmost part, we will subtract the nearest square, say a square. This will be clear when we solve an example. Let us take an example. If it is 15, say leftmost part, then I will select a 9. Nearest left square is 9. If it is a 72, as my leftmost part, when I group the digits from right to left, remember the grouping is from right to left. So if it is 72, then I will select 64 as the nearest left square and proceed accordingly. Now, a square, so first digit of my square root will be a. Now from here, Bhaskara differs. He says pankti. In that verse, there many times the word pankti is there. Pankti means a column. What is to do in the column, next column, is find twice a. After finding a, find twice a. 2 stars are denoted. Say number twice a is say 2 star. Then divide by twice a is the third step. But before dividing, don't forget to bring down the next digit below and then divide by twice a. If quotient is b of that division, find twice b. But that twice b is to be written according to that alignment, one digit to the right. See the picture of that. Then subtract b square. Now the fourth and important step, if necessary. If you have 4-digit number, when we subtract b square, procedure ends. But for 5-digit number, 6-digit number, 7-digit number, you have to continue the process. So divide by 2ab. 2ab means it is not a into b, but place wise you have to kept. Means if my first A equal to 5 and B equal to say 3, then I will divide by 2 times 53. That's why that brackets are written that way. That those brackets AB denote that you have to combine the number or write a number in decimal system. AB is to be written in decimal system. A first tens place digit, B unit place digit. Divide by twice A. If the root is C, I will find 2 times C, write according to our structure. Then subtract C square. Then divide by 2 times A, B, C. And the process will be continued till we reach the unit place digit. I suggest you to write this column number 1 at least, or the full table before you, so that you can refer the table when we perform the numerical calculations. So first grouping, second step, subtract nearest less square, write root A, and in column twice A. Divide by twice A. Quotient is B, say, write twice B in the column. Subtract B square. Every time, I repeat again, every time after every step, I will brought down the digit from the given number. Then the operation. Then divide by 2AB. A tens place digit, B unit place digit. If C is quotient, write twice C. Then subtract C square. Then divide by 2 ABC. A is 100 place digit, B tens place, and C unit place. Quotient is D, write twice D, and so on. Of course, for 4-digit number, as I said, subtract B square is enough. For 5, 6, 7-digit number, you may go to further. And for 8, 9, 10, you may go to further again. AB, twice A, B, C, D, then subtract D square, etc. But the process is repeated with earlier digits as and when we got it. Final answer of the problem will be root is A, B, C, D, written in a decimal format. We start with the simple example, 4-digit first, then 5, 6, 7, 8 as the time permits. Start. Find the square root of 1156. You will write the table as written in the screen. Groups are select 56 from right and 11. 2 groups only. 4-digit means 2 groups. And 1 column of root, 1 column of pankti. So we subtract 9. Nearest less square 9. Whose root is 3. In pankti, we will get 6. 2 times 3. So first select nearest less square 9. Write its root 3 in the root column. And pankti is 2 times A. Just refer to your note which you have written earlier. 11 minus 9, 2. Brought down 5. Now divide by 6. Remember, divide by 6, twice A. So pankti is written for that purpose. Digits in the 3rd column or 4th column are written for that purpose to get a proper divisor. Divide by 6, quotient 4, 24. Write 0, 8. Don't write 8 below 6. Write 0, 8. And then 24 subtracted from 25 will give 1. 6 is brought down. Subtract 4 square, 16. We get 0. We can discontinue here only because we have exhausted all the digits of the number 1156. Not because we are getting 0. Remember, the procedure we need to end only after we exhausted all the digits. It may possible that while doing subtraction, you may get 0, but don't cut the procedure there. We always reach up to unit plus digit by repeating the procedure. Answer is 34. Now, what is the relation between this 34 and those Pankti digits? When I add 6 and 08, I got 68. So this becomes a test whether the answer is correct or not. So if my answer is 34 and addition of the digits in the 4 column is such that it is 2 times the answer, or conversely, if root is half of the Pankti digits, Pankti dalam, as it is the word used by, dalam is divided by 2. If it happens, then answer is correct. You need not worry about the answer. If not, then some mistake is there definitely, and we have to check the answer. I hope you are getting it correctly. Let me repeat. Nearest square 9, write 3, 2 times 3 becomes 6. Subtract 9 gives 2, 5 brought down. Divide by first Pankti value, that is 6. 4 quotient, 24. 25 minus 24, 1. 6 brought down. 4 times, 2 times 4 is 8. Then subtract 4 square. Answer is 34. Now try this. 3969. Find square root of 3969. 39, nearest less square is 36. So root is 6. Fourth column give me 12. 39 minus 36, 3. 6 brought down. Divide by 12. Don't divide by 6. Divide by 12. 2a. Always remember that. 3 is the root. Quotient. 36. Answer is 0. Pankti is 06. Write it accordingly. Then 0. As I said, don't terminate your process even after getting 0 because we have 1 digit left still. So brought down 9. Subtract 3 square. Now it's okay. We are getting 0. Answer is 63. When I add the Pankti digits, again 2 times relation exists. 63 and 126, or 126 divided by 2. So for 4-digit number, 3 steps are enough always. Try this. 8836. I have selected perfect square number. Don't worry about it. We will be considering non-perfect square by the same method little later on. Two examples, 8836, 3969. Just to have a practice of writing the digits properly and that algorithm. Subtract nearest less square. Find a and twice a. Divide by twice a, etc. $94, first answer. For 3969, it is 63. I'm sure everybody is ready with the answers, 94 and 63, so that I can proceed for 5-digit perfect square number. One step further.
Correct, sir.
Okay. Find the square root of 75076. Same chart. Groups from right, 76, 50, and 7. Leftmost group will have 1 digit 7. The number of groups always tells us that this particular square root will have 3 digits. Because there are 3 groups there, so at the outset, I will know that my answer will have 3 digits. Now start. Nearest less square to the 7 is 2, or sorry, 4. Root is 2. Pankti is 4. 7 minus 4, 3. First 3 steps are same. 5 brought down. Divide by 4. Quotient 7 for 35. So it becomes 28. Pankti 14. 2 into 7. Write 14, 1 below 4. 35 minus 8, 7. 0 is brought down. Divide by, subtract 7 square first. Not divide. Don't forget to subtract the square. Answer.
Sir, excuse me. While dividing by 4,
yes.
we won't go to 8.
Yes.
8 4s are 32, no? Won't we get 8 there?
For that question, I was waiting actually. Okay, try that way. Try at your book.
You won't get the answer.
4 8s are 32. I will get 3 as the subtraction.
Yes.
When 3 brought down 0, I get 30. But from 30, I cannot subtract 8 square.
8 square. Okay. So we have to
That's
go
why, that's why I have selected the example. That's why we should scale down 1 digit from 8 to 7.
Okay.
So instead of taking quotient 8, we will take 7 quotient so that the subtraction is not negative.
Yes.
64 cannot be subtracted from 30. I don't say that way. It will give negative answer.
Yeah.
So this is what we always do in division also. 1 digit scale down. Then 7 brought down. Divide by 54. From where I am getting 54? 0, 4 and 1, 4. Divide by 54, remember. Or you can say 2 times 27, 54, both ways. 2AB. That's why in our chart we have written 2AB. So consider 27 as 27, multiply by 2. Same answer comes, 54. So 4 quotient 216. 1 remains, 8 in the Pankti, 8 in the last column, but 0, 8 is to be written 0 below 4. 6 brought down, 4 square when subtracted from 16 will give me 0. And the addition of the last column is 548 with my answer 274. It is correct. 274 and 548. They are 2 times. Or 548 divided by 2 gives 274. So answer is correct. 274 is the answer. So this is to be need to be very careful when we select a quotient, so that next subtraction should not be a negative number. Scale down 1 digit. You need not worry. In very few cases, we need to reduce to if with 7, even if it is not possible, we would have taken 6. Again, repeat. Nearest square divided by 4, subtract 77, divide by 54, subtract 4. If this order is kept in mind, then remaining calculations are easy. Please unmute. 88209. This is the example stated by Bhaskara in Lilavati. Find the square root of 88209. There is a special reason for that. Let us start solving, and then you will realize why this example is selected. Again, 09 first group, 28 or 82 second group, 8 will be the third group, leftmost. Nearest square is 4, 2 in the root place, 4 in the Pankti, 8 minus 4, 4. Now proceed further. Yes, Padmini ji, anything?
Yes, sir. I'm just doing, sir.
Okay, no problem.
Here we should not divide fully, is it?
Divide by 4. So don't select 12. See which number is selected. That's why I have not written those numbers. I am not saying do not divide by 12.
We will get 0.
But 0 minus 12 square will be negative number. So avoid 12. Try 11, try 10. We have to scale down till when we subtract the square of that number,
9.
Subtraction should be positive.
We can go up to 9.
Yes. Yeah. That's the reason why Bhaskara has selected the example. As I said it. Here you have to scale down many times. Even if routinely we get a 12 as a quotient, 9 will be the answer. Yes, this will be situation when we select second question 9, Pankti 18, 36 is to be subtracted. We get 1, 2, 12.
A square of 9 is to be subtracted.
Yes.
A
But
square of 9
first,
is to be subtracted from 122.
But yes, 81. Subtract 9 square. $41 is the answer. Bring down 0. Now, a divisor is to be selected. Two ways. Either you can see that it is 4 and 18 written. by shifting one digit to right, it becomes 58 immediately. Or 29 into 2, 2AB is 58. So divide by 58.
Okay.
Again, you have to think of a proper quotient.
Divide by 58 na 3 34
Start by 8. Don't try more than 8. 8 into 5, 40. 40 plus 6, so 8 is not 7. 7 maybe. Yes. 7. 7 is
7 போட்டோம்னா அந்த சப்ட்ராக்ட் பண்ணா வரும்
406. 40. Padmaniji, please unmute yourself. Four remains. 49 will be the next dividend. Subtract 7, that gives 0. All digits are exhausted. 297 is the answer, and the vertical addition gives 594. So that's correct. Just try one or two before we close today. You can select any two examples.
Sir, I did not understand the 2AB part, how we got 58.
What?
Tell that once again. In the
Which
previous
part?
example.
Which part, please?
58. How we got 58?
Yes. There are two ways. One way,
Okay.
First digit Pankti is written 4. Observed?
Okay.
2 times 2. 2 times 2 is 4. Okay. Then 2 times 9 is 18.
Yeah.
That 9,
Okay,
that 18. That 18 is written as 1, 8, 1 below 4. So don't add 4 plus 18, 22. No. The digits are written place wise. 1, 8. So 4. So it is 40 plus 18. Or 0, 4.
Okay.
40 plus 18. Exactly.
Okay.
Or if you have any confusion about the fourth column, just multiply 2 by 29. 2 is my first root. Second choice is 9. So 2 times 29 will be 58.
Okay.
If I would have more digits, let me finish. If I would have more digits in the example, then my next divisor will be 2 times 297. That is 594. If there are 6 or 7 digits, then I have to select a divisor 2 times 297, which is 594. So it becomes a job of multiplying. That's why Bhaskara says just write and add every time to get the next divisor, so that you need not multiply 2 times every time.
Okay. Thank you.
Hope you are getting it.
Yes, thank you.
Yes. Now try this. Let me close this sharing. Now, two things before we end our session. I will suggest that whenever you come next Saturday, please solve 2-3 examples of this square root taking 4 digits perfect square number and 5 digits perfect square number, 5 or 6 digits, same idea. You can extend it up to 7, 8, but that will be the next part of the session. Then square root will be followed by the cube root, or cube and cube. Cube we have selected. So square root will be followed by cube root. So please at least try 2-3 examples before we. Now, any difficulty, any comment, any suggestion?
Great, sir. It was wonderful. Very different technique. Really, we like it.
Yes. Yes, slightly different than the previous. Yes, I agree.
Yeah.
So we can, if you have no difficulty, we can close it. Yes, please.
Like we calculated 28 cube as 20 plus 8. So can we write it as 30 minus 2 as well?
Yes, no doubt, no problem. But then you have to subtract.
Yes, okay.
You can always have your choice.
Okay.
It will be a minus b whole cube type situation and not a plus b whole cube.
B whole cube. Thank you, sir.
Okay?
Yeah.
Yes. Anything? Now the things are becoming slightly heavier than earlier part, and it will become heavier as the course proceeds further. So you need to be ready for such situations. Don't worry, we will go slow. We will go step by step, and I will wait for everybody till everybody understands it carefully. I'm not in a hurry. So, Jai Gurudev. Goodbye.
Jai Gurudev.
Jai Gurudev. Jai Gurudev.
We will leave now.
Jai Gurudev.